So the way I'm starting out these notes is super, super generic. Let's say you are going to do some project at your house. And you think that the first project is going to take you or cost you about $100. And you think your second project is going to cost you about $200. So there's no reason for those. I'm just picking numbers for different projects. I've done my research. I think that's about what it's going to cost. I go and actually do my entire first project. I make something. And let's say it ended up costing me $110 for that entire project. So I can now see how wrong I was, which is what this column is. My observed minus my observed minus my predicted, which is what? $10. In words, what does that mean? What does 10 mean? I was $10 off because it ended up costing $10 what? More than I expected, more than predicted. So if it cost more than I predicted, was my estimate an underestimate or overestimate? And all of that makes sense, right? Like I'm not doing anything crazy. One thing that gets people here is, what kind of number is this? But it means, so a positive one of these actually means underestimate. So let's say our second project ended up costing us $180 instead, which means my observed minus my predicted was negative $20, which means that it cost $20 what? Less than I predicted. Which means this was a you will end up having questions that ask essentially what that just asked, but in the context of like a regression line. This is the only thing that's weird, is negative means over and positive means under. If you actually think about what's going on, it makes it a whole lot easier. So theoretically here, my predicted is my least squared regression, and you don't need to write this anywhere. My predicted is my least squared regression line. So wherever my project 1 is, I predicted it to be 100. It ended up costing 110. Does that make it very obvious that I underestimated it? Because this is my estimate line, and my estimate was under what it actually was. So when you actually look at it visually, this makes more sense. It just seems kind of counterintuitive that those are like opposite. This has been a very, very long time since I've done this one. I only briefly mentioned it, but this is chapter 3, and there have been years when I teach chapter 3 right after chapter 2 and chapter 1, which means we had just kind of done this. What seems like years and years ago, we did a normal probability plot. And on a normal probability plot, we graphed our x values versus all of our values as a z-score. So just write this with me. This is actually the last option on second stat plot. Don't draw the dots with me. But we would end up getting something that looks like this. Does anybody remember what we're trying to look for there?
If it's normal and if it's linear.
We're looking to see if the data is normal by seeing if the normal probability plot is linear. You don't need to draw the dots. But I do need you to write that. So we were checking to see if the data was normal. How did we know if it was? Because the normal probability plot would look linear.
But you don't want us to draw on it?
You don't need to. You need to know what the labels are. The reason I bring that up is because that looks very similar to what we're doing here, except we're checking something completely different. And these are the two graphs that we do where our x-axis goes straight through the middle. So now we are going to make a residuals plot. It is going to be our x values as our x-axis again. It is going to be residuals over here. I haven't even told you what those are yet. What we actually just did was residuals. And we are going to check here to see if the data itself is linear by checking these three things from a residuals plot. I'm going to do my own dots because I don't have that ready. All right, so let me write this first. Here on your paper, because I didn't save your room up there, I'm just going to write what I wrote there. So the very bottom on the right, left side, very bottom on the left underneath what I'm doing. So residual is where we started. I wanted to know how much my project cost. I want to know how much I thought it would cost, and I want to know how wrong I was. Sometimes I talk about residuals like how wrong you are, but it is just observed minus predicted. Can you think of anything that we've done before today that deals with something that's very similar to observed minus predicted? Past squared does observed minus expected squared divided by expected. It's still using that idea. And since we were talking about it earlier, I went ahead and wrote it on the front down here. A positive residual we decided means that we did what? Which one? Underestimate. A negative residual overestimate.
What did you say before that? That it reminds us of what?
Part of chi-squared equation is observed minus expected. The only reason I bring that up is on the orange sheet at one place is this tiny little equation that says if you get to the AP exam and you can't remember if you're supposed to subtract observed minus predicted or predicted minus observed, yeah. Alright, so we are checking the residuals plot for three things. One, we want it to have no pattern, or no obvious pattern. And I'm going to write these, and I'm going to come back and talk about what examples of ones that wouldn't be good. My longest written one is scattered evenly above and below 0 for all values of x. You might have to do another hash mark or something. Hello? Hey. She is not here. Yes. Thank you. I'm back. Oh, I thought it wasn't recording. Okay. And then our last one is that they are relatively small residuals. Like I said, I will talk a whole lot more about what those three things are. So we wrote yesterday, 2 days ago, that how do we check if it's linear? We look at the scatter plot and then residuals plot. But we didn't know what a residuals plot was at the time, so we just wrote residuals plot. These are the things that we would need to check to make sure that it actually is linear. All right, so this is kind of tying in calculator. What you just did on your homework. What's in list 1? Always. General. Your what? What's in your list 2? Which is your what? So if I want the calculator to graph a scatter plot for me, I just tell it to graph which list versus which list. Don't overthink this. This is very obvious. Right. They're already in there. They're in that order. If I wanted the calculator to make a scatter plot, so 1 versus list 2. Alright, so we're going to build from that. We already have our x's in list 1. We already have our y's in list 2. If I need to find residuals are what minus what? Observed minus predicted. Are either one of these are observed or are predicted?
No.
It's our observed and our predicted what? Okay, let me go back. It's our predicted what?
Outcome.
For which variable? I always try to predict the response. Is one of those at least in our response? Is this my observed response or my predicted response? So my observed is already in list 2. Well, to get residuals, I need observed minus predicted, which means somehow I have to figure out how to get what in list 3. So, in general, what am I going to type in list 3? How do I always predict? Plug it into your equation. So, you can apply an equation to a whole list. I'm actually going to show you a different way to
What
do
are we
that.
plugging into the equation?
You plug the whole equation in as list 3. Which again, I'll show you in a second. So, red letters here, what's going to go in our list 4?
Y minus list 2 minus list 3.
So, this is going to be my list 2 minus list 3. What's in my list 2? My observed. What's in my list 3? My predicted. So this is going to become my what list? My residuals list. General idea, that makes sense of where we're going, right? Even though I haven't told you technically how to do it in the calculator. So when we graph a residuals plot, I probably should have changed this. It actually ends up looking like this. Your x's still go on your x-axis, and we have residuals as our y-axis.
Ignore the line on the bottom.
Yeah, it's your scatter plot. Your 0 can be go through a scatter plot, but your residuals plot always puts your x-axis in the middle, generally.